Can this function's average rate of change and derivative have the same value? I'm going to answer that question using the mean value theorem in this video later on, but for right now, let's first find its average rate of change over the interval from 0 to 3. Now, this is straightforward because you take both ends of the interval, and for the values both 0 and 3, you plug them into the original function and see what you get. So f of 0 is going to be the square root of 1 plus 0, giving an output of 1, and then f of 3, the upper end of the interval, is going to give you the square root of 1 plus 3, giving an output of 2. Now, if I were to look at a graph, the average rate of change for the interval would look like a secant line going from one side of the interval to the other. And the way you calculate it is actually finding the slope, right? You basically take the output of the upper end of the interval's y value, which is f of 3, minus the lower end, that having a y value of f of 0, all divided by 3 minus 0. Just typical rise over run or finding the slope, right? And this is going to give you 2 minus 1 over 3 because we already found the values above, and that's going to simplify to 1 over 3. And so now the big question is, if this is the average rate of change over the interval from 0 to 3 of our radical function, can the derivative also ever have a value of 1 over 3? Now, it's a big mistake to assume that that's always true. There is an example of a type of function where it is. Tell me below in the comments if you know it. But I also gave you guys a free study guide in the description below that talks about this and many other simple mistakes you might be making. But moving back onto the topic, what I want to do now is figure out the derivative function here after first rewriting the radical as a power of 1/2, because it's just easier for me personally to use the chain rule. Now, using the chain rule would give a derivative that's going to look like this. And now this is where we can use the mean value theorem. And before I state what the theorem is, we need to answer something about the original function I gave you. So for this original function, from the interval from 0 to 3, is it continuous everywhere? Well, yes, because you don't have to worry about dividing by 0, right? Because that would happen when x is -1, and that's outside the interval. Now, is it also differentiable everywhere from 0 to 3? And the answer to that is yes as well, right? Because if you look at this derivative function, again, for the interval of 0 to 3, we would never be dividing by 0. So because those two conditions are met, what the mean value theorem is saying is that for the open interval from 0 to 3, in other words, somewhere in between 0 and 3, if we know that the average rate of change was 1/3, we can guarantee that somewhere in there, the derivative function will also be 1/3. So I'm going to go ahead and just set the derivative function to 1 over 3. And we want to find the value of x, which we would call c, where this is actually going to be true. And so by simple arithmetic here, I can just multiply both sides by 2, giving me 2/3 on the left here. And then as the next step I'm going to take, you don't have to do all these steps. It might be quicker for you, but I'm just trying to help some of you out that are trying to follow along. I would just rewrite this in such a way where I bring the radical to the denominator. That way it's very clear that I can take the reciprocal of both sides. And then solving this after squaring both sides, you would get 9 over 4 on the left. And then subtracting 1 would give this answer, where you have to also make sure that this is in the closed interval between 0 and 3, and it is.